Welcome to AI Frontiers. Today, we explore the adaptive frontier of robotics research, focusing on computer science robotics papers published on December 16, 2025. This snapshot of 21 papers reveals a field moving decisively from static programming toward adaptive learning, building resilient, collaborative, and increasingly self-aware machines. The future is being written in code right now. Consider the kitchen conundrum. A robot in your kitchen reaches for a moved mug. The coffee tin lid is tighter than in its training videos. Standard robots freeze when reality doesn't match their programming. But what if a robot could pause, adapt, and learn on the spot? This isn't science fiction. It's today's research frontier, separating today's robots from tomorrow's partners. The urgent evolution of robotics research moves beyond predictable, pre-programmed lab performers toward real-world partners. This involves learning from mistakes, adapting to new situations, understanding human nuances for safe collaboration, and building trust through robustness and self-awareness. Today's breakthroughs are actively rewriting the rules of what machines can learn to do. The new paradigm of computer science robotics is less like a master clockmaker's workshop, precise but fragile when conditions change, and more like cultivating an intelligent, dynamic ecosystem. This ecosystem has deep roots in perception and mechanics fundamentals, sturdy stems of robust control, and budding flowers of adaptive learning and human collaboration. The first dominant theme is adaptation and continuous learning, creating the perpetual student. This moves from static programming to lifelong learning. Systems like EVOLVE-VLA, which are vision language action models, improve through their own interactions. Like a chef who tastes and adjusts rather than just following recipes. Another, Arcade, allows robots to continuously update their internal models of body dynamics as conditions change. This builds resilience through practice and feedback. The second theme is robustness and safety in uncertain environments, building armor against chaos. The Cold Fusion project treats cars as teammates, sharing lane data to extend collective perception by up to 200%, like a flock of birds navigating as one. Elsewhere, drones are stress-tested in real boreal forests, not just simulation. New safety metrics and massive GPS-free datasets like Odyssey are being developed to measure and improve performance where it matters most. The third theme is collaboration and ergonomics, framing the robot as a human teammate. This involves interactive motion planning that uses mathematical, ergonomic fields to optimize for human posture and comfort. Research also explores trust dynamics, examining how a robot's facial expressions or tone affect human trust after a mistake. Systems like cafe television use immersive visuals to reduce operator strain in teleoperation, making robots extensions of human will. Key findings from the day represent genuine leaps forward. EVOLVE-VLA achieved a 20.8% success rate on completely unseen manipulation tasks, versus 0% for standard models. The chip method taught humanoids compliance through hindsight perturbation, creating a single controller for both dancing and delicate manipulation. The super framework could predict navigation failures 1.6 seconds in advance. And collective intelligence, as in Cold Fusion, extended perception beyond individual sensor limits. Our paper of the day is the Super Framework by Gauss and colleagues, titled Sensitivity-Based Uncertainty-Aware Performance and Risk Assessment in Visual Inertial Odometry. It solves a critical problem. Robots need to know when they're getting lost. Visual Inertial Odometry, or VIO, provides precise, GPS-free motion estimates, but current systems don't measure their own confidence. Super gives robots the ability to ask, "How sure am I?" moving from blind faith in algorithms to informed, actionable trust. The beauty of Super's methodology is that it works without adding bulky neural networks. Instead, it taps into the existing mathematics of the VIO optimization process. It analyzes a part of the optimization matrix called the Schur complement to extract sensitivity signals. It combines this sensitivity data with scene quality and error trends to produce a real-time, risk indicator, metric. All this is achieved for a remarkably low computational overhead of just 0.2%. The practical impact is a form of robotic self-awareness. Super could predict significant trajectory errors roughly 1.6 seconds before they happened, with 20% better accuracy than previous methods. It triggered safety policies like slowing down, with an 89.1% recall rate. This is the robotic equivalent of a pilot's instrument cross-check, building machines that know when to proceed with caution, reflecting a profound human responsibility in design. Future directions point toward a growing, integrated garden. This includes lifelong learning at the edge, where robots adapt to specific environments over time. Collective or federated intelligence, where fleet wisdom grows from individual robot experiences. Hardware-software co-design, creating new robot bodies for new AI capabilities. And ubiquitous self-assessment modules, giving every critical system a built-in conscience. The vision is an adaptive ecosystem of specialized, collaborative machines. In conclusion, the frontier has shifted from performing tricks to cultivating capabilities. This is seen in adaptation when plans fail, like EVOLVE-VLA's test-time learning. In collaboration without harm, like CHIP's compliant control. In collective sight, like cold fusion's shared perception. And in prudent self-awareness, like Super's risk assessment. Robots are becoming more than tools. They are becoming learners, teammates, and cautious explorers. This presentation was created through AI synthesis and human expert review. Content was synthesized using the GPT DeepSeek model. Text-to-speech was generated using Google's technology. Image concepts utilized stable diffusion. A human expert reviewed the synthesized content. References are drawn from 21 research papers published on the arXiv preprint server on December 16, 2025. While reviewed, some oversights may still exist. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This content uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.